Hi, this question is given in daily random 5 questions organic part 5 in chemmasters.online. Okay, so the fourth question, we need to give first we need to give R and S notations to the substrates. Okay, right. So if you observe R notation, just for that, first we need to give numbering priorities as per RS nomenclature. Okay, so after giving numbering priorities, we get clockwise direction. Okay, so then whenever we get clockwise direction, so that indicates R notation according to RS nomenclature. Okay, right. So in this, if you observe next one, that is S notation. For that, we are getting anti-clockwise direction, that is numbering priority is in anti-clockwise direction, so that's why its notation is S. So here whenever you are going to give R and S notations for stereochemical substrates, okay, or stereochemical chiral centers, and when we have above or below planes, the groups are on above or below the planes, so then we need to consider the fourth priority group. That means if fourth priority group is backside or on the plane, then we need to give RS nomenclature R and S notations as per we get the numbering. That means if it rotates anti-clockwise, we need to give S notation. If it rotates clockwise, we need to give R notation. Okay, but if the fourth or least priority group is above the plane of the substrate, okay, then we need to give opposite notation for it. That means if we get S notation, then we need to give R, and if we get R notation, we need to give S whenever least priority group or fourth priority group is above the plane, okay, or towards us, right? Okay, right. After giving R and S notations, then look at the salt. So Echen-Moser salt. So Echen-Moser salt is a methylating agent. Okay, right. So what happens on nitrogen on that salt, that means Echen-Moser salt, it has a scarcity of electrons, so that's why it tracks electrons from the double bond of carbon. Okay, so during that process, the electrons on double bond on that ring, that means simply substrate, so just look at it, arrows, so the electrons on double bond drags onto that methylene carbon of Echen-Moser salt. Okay, so after that there is the formation of carbocation, so due to that Echen-Moser salt dragging electrons towards it. Okay, then here is a possibility of Mervin-Pondorf rearrangement. That means here whenever we observe Mervin-Pondorf rearrangement, we need to observe periplenarity, simply anti-periplenarity to the leaving group, that means simply the alkyl group. Okay, alkyl group and leaving group. So alkyl group which is shifting onto the carbonyl cation or onto the carbon of leaving group, they must be anti-periplanar. Okay, so in this, if you observe here, the thick black lines are in anti-periplanar to each other, so that's why that group, that means that bridged group shifted onto that carbocation. So during that process, the oxygen and hydrogen bond cleaves, and the electrons drags onto that oxygen and carbon bond and forms carbonyl compound or carbonyl functional group. Okay, right. And after rearranging it, we get this molecule, this product. Okay, and on this, by applying metachloroperbenzoic acid, and it oxygenates on nitrogen. Okay, and then on further heating of this oxygenated substituted ring substrate in presence of DMSO, on that particular heating, so there is the chance of possibility of cope elimination. That means the bulky group ligand, that is oxygenated amine, easily eliminates by dragging proton onto it, which is in 1,2 position for it. Okay, so by that we can get alkene group on it. So that is the final product of a fourth question. Okay, so right here many my YouTube followers are asking to give complete explanations with answers to the daily random 5 questions, but sorry, I cannot give complete and full detailed explanations for you, because they are reserved by the paid aspirants in my chemmasters.online website. Okay, so I'm giving you here to help you to please try to solve them, and if you have any doubts, and I may try to give answers. Okay, but if you are interested, please come to my website and get them completely. Okay, right, thank you.